Guys, and welcome back. So in this lesson, we are going to start looking at reflections. So our objectives today are that students will identify the rules of reflection in the X and Y axis and then perform reflections on the coordinate plane. So first we see a definition for reflection, and a reflection is just the flip over a specified line. So everything's going to look opposite. And this is an isometry. And so we just need to define isometry, as we forgot to in translations. So an isometry is a transformation that results in a congruent figure. So you're going to have that triangle ABC will be congruent to triangle A prime, B prime, C prime if the reflection or translation is an isometry, or if the transformation rather is an isometry. A line of reflection will be the line that is the perpendicular bisector, a little unit 1 vocab there, of the image and the pre-image. So what that means is if you were to connect the image and the pre-image with a segment, the line of reflection would be the midpoint of that segment and be perpendicular to that segment. So when you want to reflect something over a line, then you need to draw a line that is perpendicular to that line and then draw beyond that point the congruent amount. So if we look at this picture here, if I wanted to find the reflection of point E, I'm going to take my ruler and I'm going to put it on E right here, and I'm going to my protractor is not working very well. Draw it so it looks like it's about 90 degrees, and then I'm going to kind of place it here so that I can easily get a measurement. So I'm going to draw a dotted line along my ruler down, and then I'm going to go the same amount down here. So you can see that this line is now perpendicular to my line of reflection, and I have the same length going down. So this will be E prime. So if a point is on the line of reflection, then you can't draw a perpendicular bisector to it because it's on it. So that means that if the point A is on the line of reflection, then A prime will equal whatever your original A was. So you can imagine if you were drawing for D, you would have your point D right over here. It would be about right there. That would be D prime. F prime would be right here, around right there. So you can see if you draw lines to connect your points, then it will be a straight perpendicular bisected line. So what that's saying is that this segment here should be congruent to that segment there. See if you can imagine where your points would go in the triangle GHI reflected into this line R. Your points should have been in about those positions, and if you were to draw a line, then it should be perpendicular to your line of reflection, and this segment should be congruent to that segment. It's much easier to do this on a graph. So I've already graphed these points for you, and you are going to reflect the figure on the x-axis. So that means that you need to count how far away each point is from the x-axis, and then go down the same amount below the axis. So this point here is 1, 2, 3 above. So then I'm going to go from the axis and go 3 below. Remember, the x-axis is your horizontal axis. Then I'm going to go from this point, I'm going to go down 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 more. And then from this point, I'm going to go down 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 more. And then I can connect. So I can see the point 2, 3 came down to the point 2, negative 3. So I'm going to write 2, negative 3 up in my box. I can see the point 1, 5 went down to 1, negative 5. And that the point 3, 4 went down to 3, negative 4. Looking at the second one, this point is on the x-axis, so it's not going to move. It's just going to stay right there. This point, negative 3, 4, is going to come down 4, so then I'm going to go down 4 more. And then negative 6, 2 will come down 2 to go 2 more. Think about your line of reflection as a folding point. If you were to fold your graph over on the x-axis, and the x-axis was where the fold was, where would your picture or your figure end up? So negative 3, 4 ended up at negative 3, negative 4. Negative 2, 0 stayed the same. And negative 6, 2 went down to negative 6, negative 2. You try and do the last one and see if your coordinates, come back to see if your coordinates match mine. For the last one, you should have gotten that the coordinates were negative 2, 3, 3, negative 5, and 4, 2. So when we compare, if we want to write a rule, then we want to compare our tables. So we can see that the x values in each table all stayed the same. They did not change. But we can see that our y values, on the other hand, all changed. The y values that were positive became negative, and the y values that were negative became positive. The only y values that didn't change was the 0, and that makes sense to us because that point was on the x-axis. So if we want to write a rule that shows when we reflect over the x-axis, the sign of the y will change, then we're really multiplying y by a negative 1. The multiplying by 1 will keep the number the same, while the negative will change the sign. So our algebraic rule will be that xy will map to x comma negative y. So the sign on y changes, the x stays the same. Now let's see what happens when we reflect our figure over the y-axis. So I have drawn all the figures down there for you. And we're going to do the exact same thing. So I've plotted the points. So now I'm going to reflect into the y-axis. So I'm going to count how far away each point is and then go that far to the other side. So this first point was 2, so it goes 2 over. This point goes 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And then this point will go 1, 2, 3, and then 1, 2, 3 here. So we see this figure. So 3, 1 became negative 3, 1. 2, 6 became negative 2, 6. And 5, 3 became negative 5, 3. Looking at the second one, 0, 2 is on the y-axis, so it's going to stay the same. Negative 3, 2 is going to go 3 to the y, so then 3 past it. We'll bring it to positive 3, 2. And negative 5, 3, negative 3 will go 5 to the y-axis, so then another 5 over brings it to positive 5, negative 3. You try and do the last one. That last triangle was a little hard to draw, but as you can see, your new coordinates are -1, 2, 3, 5, and -4, -2. So when you're looking at your graphs, you see that now your x values are changing while your y values are staying the same. So a rule that you could write is that just like over the x-axis, your xy is going to map to the opposite of x, y. So the sign of x will change, but the number will stay the same, and the y value will stay the same. In class, we will cover the rest of these examples and do some more. Hope to see you then.